In this video, we are going to talk about subatomic particles. Remember that in a previous video, we mentioned that the atom is the simplest form of matter that retains the characteristics of that particular element. So if I have helium and I keep cutting down the sample and it goes smaller and smaller and smaller, I reach a point where I have individual atoms of helium, but then once I divide the atom further, it is not helium anymore or any other element. We now know that atoms can be subdivided into several different particles, but a lot of work was put in late 1800s into the early 1900s, lots of experiments to try to figure out what these subatomic particles were. The first experiment that yielded results toward this was the J.J. Thomson experiment that revealed the fact that atoms contained these charged particles, and they were negatively charged, and they were called electrons. Thomson also thought that because the atoms themselves are neutral, there must be something that is offsetting this negative charge of these particles. And later on, we know that those particles were found, and they were called protons. Thomson proposed a model for the atom, which he called the plum pudding. In the US, we don't really have plum pudding as a dessert. Nobody that I know has ever had plum pudding, but we do have chocolate chip cookies, and it is very similar. His model proposed that the electrons are these negatively charged particles, just like the chocolate chip cookies, that are interspersed within this area that is positively charged. And the rest of the cookie then is that area that is positively charged, the sphere. The next important experiment was the Rutherford gold foil experiment, in which he used a source of alpha particles that were charged, positively charged, and he directed them at a gold foil. And some of them, what he noticed was that some of them were deflected, some at smaller angles, some at larger angles, similar to when you're hitting a billiard ball and you hit a ball head on or you hit it at an angle. Depending on the angle, there's a deflection, and if you hit it at a large angle, the deflection is smaller. If you hit it head on, the ball comes right back at you. And that is what he noticed. He then named that area, so the core of the atom, he named it the nucleus, and it figured out that it was very dense and contained what he called positively charged particles named protons. Chadwick is another scientist that determined that the nucleus had this extra particle called the neutron, and it was called a neutron because it is not charged, it's neutral. The dense core, the nucleus, contains nearly all the mass of the atom, so it's pretty heavy and pretty dense. The three subatomic particles then are the electrons, which are negatively charged, the protons, and the neutrons that make up the nucleus. The protons are positive and the neutrons are negative. Because the atoms are neutral, we know that atoms of any element are neutral. That means that the number of electrons has to equal the number of protons. Therefore, if we know what the type of element is, we know the symbol, we know the element's name, we know the Z number, which is the number of protons, we can also figure out what the number of electrons is because they're equal. So in conclusion of these experiments, atoms are neutral. They have no overall charge because the protons and electrons equal each other. Atoms contain, therefore, an equal number of electrons and protons. The number of neutrons, though, in an atom can vary, and it is not going to change the neutrality of the atom because they're not charged. Let's take a look at a sample problem. In the following table, I have several different data sets that contain numbers of subatomic particles. Which of the sets represents neutral atoms? For those that do not represent neutral atoms, let's determine what the charge is based on the number of subatomic particles. Well, we know that the neutrons don't really carry a charge. So we focus our attention to protons and electrons. The only time that we have a neutral atom is when protons equal electrons. And in this table, I notice that A and C have equal numbers of protons and electrons. That means that 10 protons offset the charge of 10 electrons, or 9 protons the charge of 9 electrons, making those atoms neutral. The other two, B and D, do not have neutral atoms because we have an excess of one or the other. To figure out what the charge is, then, we look to see what excess do we have. So what do we have in excess? For B, for example, we have 12 protons, but only 10 electrons. To figure out the charge, I take the difference between the two, 12 minus 10, that gives me 2 extra, and they're protons, which means they will be positive charges. So for B, I have a charge of +2. For D, however, I have 17 protons and 18 electrons. To figure out what the charge is here, once again, I take the difference of the two. 18 minus 17 gives me 1, and because I have more electrons, that 1 extra is going to carry a negative charge, and therefore I have an overall charge of -1 for D. Now it's time that you try a couple of problems. For this one, you have a picture. This diagram, so you have 3 different diagrams. Which one represents a neutral atom? If you do not have a neutral atom, what is the charge? And lastly, you have a table where you have an overall charge, you have protons, and then you are asked to figure out electrons or protons or the charge. So we can figure that out exactly by knowing whether the charge is positive or negative, how much. That's going to tell us how many more protons are to electrons or electrons to protons. If I don't have a charge, that means that protons and electrons are equal. So give it a try.